Intro music is what would be playing if I had intro music. I should probably get on that. Anyway, here's some stairs. Here's what a final project could look like. It's kind of cool. They can be floating, they could be not floating. They can be on a curve. You don't have to model them. Open a new Blender file. Delete the default cube. Add in another cube. Why? It's kind of more fun that way. Scale it to size 1. Make sure that if you scale it in any other way, you apply the scale. Now, add another object. We're going to add a plane. Add a geometry nodes modifier and change this to geometry nodes. We're going to get rid of that noodle because we don't need it. We're not going to use the geometry. Add a grid node and connect it to the output. Add a transform node between the two and set the rotation X to 90. Take the grid node vertices X input and plug it into the group input. Rename it stair count. Now unplug it from the vertices X node and instead plug it into the size X and size Y input. I add a reroute there just to make it a little easier. Add a math node set to add. Set the value to 1 and plug that into the vertices X and vertices Y. Now take another math node and set it to divide. Divide by 2. Now combine X, Y, Z. Plug the X and the Z into the divide node. Keep the Y as it is at 0 and plug that into the translation input of the transform node. Now the stair count changes the size of the plane, but not its position. Next, we're going to add an attribute separate node. Set the vector to position and the results to px, py, and pz respectively. Now add an attribute math node. Change it from add to compare. Set a to px, b to pz, leave c blank, and set the result to keep mask. Add a point separate node. Set the mask to keep mask. Connect geometry 2 rather than geometry 1 to the group output. Now you can see we have points along px equals pz. Add a point instance node. Set the object to the cube stair that we added earlier. Look, it's kind of stairs. Next, add a point scale node. Set it between the point separate and the point instance. We can control the size of the stairs, but not where they are in relation to each other. That could still be pretty useful most of the time. So we're going to take the vector input to the point scale node and add it to the group input and rename it stair object scale. Take the last 4 nodes that we added and press Ctrl-Shift-D to duplicate them. We're going to keep everything the same except change the attribute math node from compare to greater than. Add that to the geometry output so we can see what we're doing. It's everything below the other set. Now add a join geometry node and join the two outputs together. Great, it's coming right along. Unplug the second point scale's factor input and then plug it in on its own to the group input. Rename that base object scale. Take the object input of the first point instance node and plug that into the group input. Rename it stair object. Do the same thing for the second one, but name it base object, or base object scale like I accidentally did here. Now we can control the scale from the outside. Kinda neat. Set those all back to 1. Now add another transform node. Take all of the vector inputs and add them into the group input node. I move them up to the top because that makes sense to me. Great, now we can move it around, rotate it, and scale it. Scaling is the one that I always use. We're going to set the scale x to 0.275 and the scale z to 0.175. That's pretty close to standard scales in the States, 7 inch by 11 inch. Cool, great, that's kind of stairs. That's kind of cool. Now we're going to add another transform node before the one that we just added. Set translation x to 0.5 and translation z to 0.5. That way it always starts at the origin. If we get rid of the base object, then we have floating stairs. We could set it to a different object, but we're not going to do that for now. Next, add a Boolean node. This one's kind of slow, so I usually save it for the end. Set it to union and check self-intersection. What we're trying to do is get rid of the internal geometry. It sort of works, not really. A workaround I've found is to change the stair object scale and base object scale all to 1.001. That looks pretty good. That's decent topology. We could add a bevel modifier or something like that and it'd work out. Now I'm going to mute it until I actually need it because it's kind of slow. Now I'm going to add an attribute mix node. I'm not going to actually put anything in here, but this lets us shade differently. This lets us take colors from the geometry node object rather than from the cube object. You'll see I did some work on materials. We're going to save that for another video. I'm going to add a weld modifier. Hopefully there'll be one in geometry modes later. Keep it as it is. Next, I'm going to add a curve modifier. I'm going to set it to a Bezier circle that I made earlier. As you can see, the stairs follow the curve. Kinda neat. We can add more stairs than could possibly fit around the curve. It doesn't look good yet. Now, let's get rid of the base object. Oh, cool, a spiral staircase. That's kind of neat. It's a little too big though. Scale the Bezier circle down and the stairs follow it. That's pretty cool. That's a spiral staircase. There's a lot more that you could do with this. I think it's pretty fun. If you like the materials that I used in my intro, be sure to check out my hardwood tutorial. Maybe that'll help you out. Stairs, they're kind of neat.